Okay, in this video we're going to look at some patterns of relationships between angles. So first, when you cross two lines, there's an obvious symmetry there that causes the angles across from each other there to be equal. Now the fancy name for these is vertically opposite angles, where we say vertically because they're opposite at a vertex. And of course it'd work for these two as well, so it's whenever two angles are opposite each other at a cross, they must be equal just because of symmetry. Very cool. Okay, we move now to parallel lines. So parallel lines point the same direction. Okay, that's what those little arrows mean. And that makes some pretty cool patterns when you draw a third line cutting through this guy here, which we call a transversal. First thing to notice is if we take this angle here, we can slide him all the way up to there. And because the parallel lines point the same direction, the angle won't change. So that means those two angles there must be equal. And we call this pattern corresponding angles. Okay, and that pattern is that the angle can just slide back and forth like that. Now after sliding him up, we can sort of shoot him across to there, and we know that doesn't change the angle either because that's opposite at the x. So the two angles here must still be equal. Okay, and we call this pattern alternate angles. Okay, and the pattern you want to look for here is the zigzag shape. Okay, so if you sort of zigzag across two parallel lines, then the angles you make must be equal. Okay, finally, if we zoom in on just this angle here, okay, if you look at the guy right next to him, clearly they're not equal, but since they make up a straight line together, we know that the blue and the green angle add up to 180 degrees. Okay, and side note, whenever angles add up to 180 degrees, whether because of a straight line or not, we call them supplementary. Okay, but coming back out though, the pattern here is that the two angles inside a sort of container formed by the parallel lines, well, they aren't necessarily equal, but they always add up to 180 degrees. And what we call these is cointerior angles. Okay, so to sum up, we've seen a few patterns that are quite useful to know. First was when you cross two lines, the angles across from each other are equal, and we call them vertically opposite angles. Then we had three patterns involving parallel lines and a third line cutting through them. First one from the left, when you take an angle like that and slide him between parallel lines, he doesn't change. We call that corresponding angles. Second was when you form a zigzag shape with parallel lines, and the two angles you form inside that zigzag shape must be equal. We call them alternate angles. And finally, when you form some sort of container with the parallel lines and you look at the two angles you've captured inside that container, they might not be equal, but they always add up to 180 degrees. We call these guys cointerior angles. If you're a note-taking type, this would be a good time to pause and jot down the contents of this screen. Okay, so here's how we might use a couple of these patterns to work out some angles in a picture like this. We want to work out what the yellow angle up there is, given the 65 degrees and the 40 degrees that you see there. So the first thing we might do is maybe shoot the 40 across the x there. Okay, so use those vertically opposite angles. We often just want to bring the angles we know kind of closer to what we're trying to work out. Okay, then we might recognize one of our patterns because the parallel lines form a container here that tells us that this blue angle and this whole green angle up there, well, they must add to 180 degrees. Okay, we called them cointerior angles. So let's write out what that means. The blue angle is just 40 degrees from there. Then the green angle is made up of 65 degrees plus the yellow angle we're trying to find. And that all has to add up to 180 degrees. So how much sort of known angle do we have so far? Well, we have 40 plus 65, which is 105 degrees. And so what must the missing yellow angle be to make up 180 in total? Or you might be able to just see it, or maybe you'd use a subtraction or something, but either way, you'd get that it must be 75 degrees there. Why? Because, well, 75 plus the 105 that we know make up exactly 180 degrees. Okay, so that's the angle relationships we have for you, mostly around parallel lines. Okay, thanks for watching, and I'll see you around.